Max-min problems is actually called, there's no topic called max-min problems, okay? It actually comes under applications of differentiation. The way I think about it, it's an extension on all the calculus we've been doing, finding stationary points, finding turning points, but we're sort of applying it to problem-solving scenarios, okay? So what you're mostly going to find in these kinds of, in this topic, basically, is rather than you just got some y and some x, and who knows what they are, they're just random letters, okay? You're going to get scenarios like, there's the temperature of a place, or there's a height of a ball, or there's the area of a piece of paper, or the volume of a box, okay? So all of these are going to be couched in very concrete terms, okay? And so for that reason, you also need to do some more thinking. Like, it's not just the equations and you bash it out, you differentiate, you find a number. You've actually got to think about what the scenario means, okay? So we'll get to that in a second. Now, all I'm going to cover in this introduction is what's the basic approach to a max-min problem, and how does it apply, how does it relate to differentiation, okay? So what I'd like you to jot down first is, I'm going to actually give you the wording of the question, we'll talk through it, okay? So a comet is passing by Earth. So we're going to be thinking about distances, okay? Because it's distances, you might think we would usually say, let distance be d or something like that. But I'm actually going to say rather than d, because then we're going to have like dd on dt, which is a bit confusing. So I'm going to call it p for position, okay? So its position relative to Earth
we use S for displacement.
Yeah, I could use S for displacement. It's just as, it's just as random as P in some ways, but because like S for displacement anyway. Its position relative to Earth is given by the equation P equals, now I came up with one. Let's go with this. Okay. Its position relative to Earth is given by the equation blah, blah, blah. Now, because this is it's a problem-solving thing, right? Usually we're used to derivatives and all that kind of thing having no units on them, but these obviously have to have units, okay? So let's say P is in thousands of kilometers, okay? So if P was 1, okay, that means the comet is 1,000 kilometers away. P is 2, 2,000 kilometers away, etc. Okay? And T is in days. Okay? It might be hours, minutes, seconds, doesn't matter, so long as you pay attention to what they are. Okay? So the question is, what is the closest the comet reaches closest to us? And when does it happen? Okay? Now this is pretty standard for a max-min problem, okay? You've got your scenario, they'll give you some kind of equation which tells you about what governs the scenario, and then they'll pose you a question based on that, okay? And what our job is to interpret this and think about, okay, what maths am I going to have to do to solve it? Yeah?
Do they always give you the equation? Aren't there problems where they won't give you?
That's right. So I'm starting off nice and simple, okay? And we're even starting with a really simple equation as well.
Yes.
We'll get into the complexities as time passes, okay? Right, now, how am I going to do this? My first advice, before we actually apply any actual calculus to it, is can we just get a look at what this thing is doing? What's it behaving like, okay? So this thing here, we can graph this, okay? And that'll show us how's this comet behaving, and then we can start to apply problem solving to it, okay? Some people will start doing the numbers first in the equations, but I think this way will guide what kind of things you do, okay? So P equals t squared minus 2t plus 4. We can graph this. What would be the first thing that you do to work out what it looks like as a graph? Say it again.
Axes.
Axes, okay, well, let's draw it. Now, before I go on, usually we're used to a y and an x axis, right? But I don't have y's or x's here. So P is going to be my vertical axis, P, right? So that's the distance. And T is going to be my horizontal axis. Now, I will say for this question, and this is most often the case, that T is specified, it must be positive, but sometimes it's not, okay? For instance, the question might say, T equals 0 is 12 noon. 12 noon, right? And therefore, negative values for T are meaningful, right? Like T is -5 might be like 7 a.m. or something like that, okay? So just watch out. This is the usual case, but it's not always, all right? Now, because it's the case here, I'm just going to draw the positive side of the T axis. Okay? That is such a not straight line, but
Close.
I'm going to fix it. I'm going to fix it because there's a grid on this board. I don't know if you can see it from where you are, but it makes it really,
It's really faint.
it's quite faint, isn't it? Okay. So there's my P and my T axis. Now, before I do anything, I already know that the P-intercept is 4. Okay? So I'm going to stick that there. There's 0. Right? But what does the rest of it look like? How are you going to work it out? Well, it's going to be concave up. Okay, so I can see that because I've got a positive coefficient of T squared, sorry. But what else do I want to know about it? Okay, intercept is the first place to go. Okay. However, you look at it and you're like, okay, you don't have to do this every time, but you know, I've thought of this question in advance, so I already know. You can know what kind of intercept you're going to have by looking at the discriminant, right? Discriminant. B squared minus 4AC. Now that looks to me like 4 minus 16 minus 12. Okay. So if the discriminant is negative, what does that tell you? No x-intercepts, okay? So it's concave up. It's going to do something like, well, I don't even know where the axis of symmetry is, right? So,
Yeah, it's a good thing there's no intercept.
Yeah, that's-
It would be dead.
thumbs up, okay? So this is good, right?
Not dead.
I don't have any roots, so how else am I going to work out what this looks like? What would you do? Sub-in-values. I could sub-in values. What's an important feature of the graph? Okay, the vertex. That'll be useful for us. And in fact, not just is it useful to know what it looks like, but it's kind of useful to the question as well. How do you work out the vertex? Axis of symmetry. Okay. So the axis is minus b on 2a, minus b on 2a. So that's minus 2, so positive 2 on 2a. 2 over 2, that's 1. Okay, so there's my x value. So therefore the y value for that, plug it in. 1 minus 2 plus 4. 1 minus 2 plus 4. Sounds like 3. 1, 3. Okay. So that means that I've got... sorry, you caught me. Old habits die hard, don't they? Okay. P is, sure enough, it's 3. Okay. So there's my vertex. I already knew it was concave up, so this is what it looks like. And as Daniel pointed out, that's probably a good thing because if P equals to 0, the position, that means the comet's going to hit us, okay? And it did say it's passing by, okay? So at the time we start measuring, it's that far away, 4,000 kilometers. It's going to get closer. The closest it gets is 3,000, okay? And then it's just going to nick off, and we'll never see it again, thankfully, okay? Now, that's the answer to the question, right? What is the closest the comet reaches to Earth? Answer, 3,000 kilometers. When does this happen? After 1 day. Okay? So I actually know what my answer is going into this, but it's not enough to actually just say, therefore, okay, and say that, right? We've got to use calculus to prove it, right? So here's what we got.